live.
Sounds like we are.
Well, it sounds like we are now. We were just asking, how do we know when the stream goes live? So hello everybody, and welcome to this session today, where we're having the first of the Hackster Connects. My name's Adam Taylor, and obviously, if you work in the FPGA industry or the embedded industry, you may have come across some of my ramblings on FPGAs and embedded systems. And today, it's really great to be joined by Shakeel Peera from Microchip, and we're going to have a nice chat about Microchip FPGAs and their ecosystem tools, and I'm sure from what we're just talking about, it's going to stretch long and be very interesting. But before we get too far, I'll ask Shakeel to just introduce himself and tell us a little bit about you.
Yeah, 100%. Thanks, Adam. I am a big fan of your blogs. I know you write about our competition a lot as well, but they're so they're very intuitive to read, and they're never a rant. So don't let anyone tell you that. They're awesome. So I'm gonna talk a little bit about myself for a little bit, and I'll tell you a little bit about how I got here. So part of it will also be some things that might be interesting in nature from a personal standpoint as well as a professional standpoint. So I was born and raised in Tanzania, East Africa, which usually surprises a lot of people. And my first language is actually Swahili. So I'm a fluent, born and raised Tanzanian. I came to the United States in 1991 to pursue a degree in electrical engineering at the University of Rochester. I wasn't a very great engineer, but I did manage to basically finish in 4 years and join at that time what was known as AT&T Microelectronics, which is long dead. AT&T is now known as a wireless provider, but at that time it had a fairly large microelectronics business to basically construct telephonic systems. And they also had an IC business, which was one of the largest in the world. So this is where I began my career. My career began in business development. They were looking for young engineers to essentially work in an organization that was second sourcing Xilinx 3000 series FPGAs. I don't know if you remember those or not.
That's a little bit before my time, but I know. So yeah, that's like really early in the FPGA.
Very
like
early.
Second generation, right? That was the 2064 was the first one, I guess, and then this was the next generation.
Wow, that's awesome, Adam. I mean, anyone questioning your credibility about FPGAs, they should put that to rest, because that's exactly correct. And at that time, AT&T had its own foundries. So we were second sourcing Xilinx FPGAs in our foundries, and they were putting together a small marketing team, and they thought it was safe to go with new college graduates, and that's why they hired me. So I was very fortunate. AT&T then became Lucent Technologies. Lucent became a Gear, which then sold their FPGA business to Lattice Semiconductor, where I spent over a decade before I joined Microsemi, that was later acquired by Microchip. So this is the second part of this of the surprise here, which is unusual for many people in the FPGA industry, is that I've spent my entire career, save about 6 months in custom ASICs, my entire 30-year career has been spent with FPGAs. FPGAs in Allentown, Pennsylvania, which is where I'm located. So hopefully there was a mix of history and some unusual truths that I think you may not find in the FPGA industry.
Yeah, that's really interesting. It's interesting that you've kind of like, you started out with like AT&T and back when companies had foundries, right? And there was a lot of this, and then you've sort of lived through all the mergers and the acquisitions, to where we are today. That's actually quite impressive. So, and Tanzania as well. That's quite
it's quite a long journey.
It's quite a long journey from Tanzania to the US. So that's really cool.
And but very good.
Yeah, no, it's excellent. So I was going to ask you actually a question. If you've got what's one thing? I know you've given away that you're from Tanzania, but like, what's one thing technical or something about your career that might, apart from the amazing 30 years, obviously in FPGAs, that people might be surprised to learn about you?
So, I've already given out all my personal secrets, but I think the one thing that people may not know, and this is about the history of FPGAs, actually, it's nothing personal to me, is that the first high-end FPGAs were not created by Xilinx. They were actually born out of the efforts from AT&T Microelectronics and Lucent Technologies, and I was a proud part of that innovation. And that innovation occurred because the first routing architectures for high-end FPGAs were actually born out of an innovation by Bell Laboratories that used networking infrastructure as the basis of doing FPGA routing architecture. These things that we see in terms of routing hierarchies, long lines, short lines, mid-level lines, that was born out of theories in telephonic networking theory. So I think most people today do not realize it, but that's one of the things that I had witnessed.
That's pretty cool to be in there right at the beginning to witness that. And honestly, I had no idea that was where a lot of the sort of the routing ideas and the routing technologies came from. But I guess now's a good point, actually, while we're sort of taking a trip down memory lane. Obviously, here we're here today to talk about Microchip FPGAs and everything. But they've actually got a really interesting storied background, because I first came across what are now Microchip FPGAs back when they were Actel, back in sort of around 2000, I think around 2003, 2005 was my first interaction with them, with the Pro ASIC Plus FPGAs. So can you tell us a little bit about that journey that Microchip's been on and the history of it all?
Yeah, I think we can talk about history in two ways. If we get a chance, I'll talk a little bit about general FPGA history as well, because there are quite a bit of misconceptions about FPGAs in general back then and today. But let's talk about the Microchip FPGA journey. I think foundationally we need to realize that when I started in 1995 to today, in the United States alone, there have been 20 to 25 companies that have attempted to dabble in FPGAs one way or the other. What we do know today is that almost all of them failed. Almost all of them failed.
Yes.
Yeah. At one point, even, as I said, AT&T had an FPGA line, and even TI had an FPGA line.
Yeah.
And both of them either got acquired or they failed. The ones who survived are the big four, right? Xilinx is now part of AMD. They are the dominant player. Actel is now part of Microchip, and we'll explore that a little bit as well. Altera, after some difficult years with Intel, is now attempting to be a standalone FPGA provider once again. And then there's Lattice. We have a couple of others who are in extended startup mode. They're around. And all these startups collectively have low to mid single-digit market share, right? So this is a very difficult business. It's a very sticky business for those who survive. It's also a very difficult business to enter. And most of this is related to software being a big barrier to entry. And I'm 100% sure we'll talk about software at some point.
Funny you mentioned that, yeah.
So most of today's startups, other startups, are in mainland China. They're in various stages of foundation, and with government help, they're basically trying to penetrate their own domestic markets, but very little presence in export markets. So again, as I said, it's worth mentioning again that many of the suppliers fail because of IDE software, because that continues to be proprietary, because one is dealing with proprietary custom logic that is programmed with the user's customer proprietary design. So there are three proprietaries in a row, right, in the sentence itself, which means it's very, very difficult to do. Moving vendors, therefore, becomes very difficult. You just can't move from one vendor to another. And no matter how good your hardware is, software becomes the barrier to entry. The closest metaphor that we have today is in the GPU world, right? NVIDIA has built a moat, for example. It is because of the development system, not because someone else has better hardware, and this becomes very, very difficult to replace, right? So
Yeah.
if you take that as a foundation, I'll tell you a little bit about my microchip journey. If you didn't have any other questions, Adam.
No. I mean, that's really interesting. I think like you talk about how software becomes a challenge, and I think it's definitely the key thing. I'll get shouted at for this by people, but the silicon is kind of like the easier side of it, but the software side of it is very definite. I know it's later on down the conversation. It's something I definitely want to talk to you about. Is like tool chains, a little bit about open source and things like that. But no, please carry on with talking about the story.
So the tail end of the story is that Microchip did not originally design or market FPGAs. Okay, their introduction to the market actually came with their acquisition of Atmel in 2016. Atmel had legacy low-end, discontinued FPGA called the AT series, and which they still continue to sell. But I would call this a test of fire. Okay, so Microchip's real test of fire came with their acquisition of Microsemi in 2018, which had earlier acquired one of the big four. We talked about Actel.
Yeah, Actel.
Right. So this was in 2010. So Actel was the historical pioneer of non-volatile FPGAs, which I know that you use as well, and you know why you use them as well.
Yeah, we'll talk about that in a little while, but yeah, they're quite interesting, the non-volatile FPGAs.
That's correct. So they started with anti-fuse FPGAs in 1985, then evolved towards reprogrammable non-volatile FPGAs, primarily using things like Flash and Sonos. PolarFire, for example, that I know you wrote a blog about is based on Sonos. So through many market gyrations, basically SRAM FPGA had become very dominant, and they're still dominant today, right? And where Actel had niched itself into was basically high reliability FPGAs for space and defense and avionics, all right, and other mission critical markets, where SRAM FPGAs weren't as good because they were vulnerable to radiation and required external configuration memory. In 2011, we, as an organization, had a renewed focus. Basically, we had stopped growing because we're completely dependent on a niche market. So, post-acquisition of Microsemi of Actel, we basically decided to enter the mainstream market. So we introduced the Smart Fusion 2 and Igloo 2 devices. Again, I know you're a user of that, and they were originally designed to compete with low-end FPGAs like Cyclone and Spartan. And I think the question that will be asked is, how the hell do we possibly hope to compete? How, right? The answer was easier. It was in front of our face. So what we tried to do is we shine the light on the innate traits of non-volatile technology, which is basically transistor, without getting into transistor logic theory, non-volatile memory is tens of times less leakier than SRAM technology. Okay, yes. That basically gives us much, much lower power. Success is when technology innovation intercepts opportunity, which intercepts luck, and that's what happened to us. Basically, this low power thing became a thing because edge devices started to become more intelligent, and because you're an edge device in a thermally constrained environment, you need to put horsepower into this edge devices. This is how we became a growth engine. Security started becoming important. Security started becoming very important right now. And we were a 2-decade-long leader in cybersecurity for FPGAs because of our legacy with the defense department. And we started offering that in the commercial market space. So that was the genesis of our decade-long growth. If you measure the past 10 years, then the thing that you will be surprised to note, and your listeners will be surprised to hear this, the most successful FPGA company on the planet in terms of market share growth and revenue growth is actually Microchip FPGAs. When we decided to make this pivot, we were about 4 to 5% market share. Today we're at 9 to 10%.
Yeah.
For a 35-year-old company to have that kind of growth is unusual. So, that's kind of our history. Now, Microchip has proven to be a very good custodian of this business and has invested in this ethos without any interruption. So, we are happy to continue this growth journey.
That's interesting you mentioned that, because around like around like 2011, 2012, there seems to have been a lot of change in the technology area in FPGAs in general and their applications. It's quite interesting that you mentioned about sort of the coming needs for low power, for security, and obviously flash based, no external chip, it's live at power on. It was real, like you say, it's a coming together of luck, opportunity, and just good product planning and good engineering. So that's quite interesting. I mean, all of my experience, actually, you mentioned a couple of times that we do a lot of microchip work. All of my experience with microchip has basically been around that niche market that you've talked about. The aerospace, the defense, the space. In fact, I happen to have a board sat next to me, one of the boards that we designed for what will be flying on the European space mission for Plato,
Yeah.
which uses your rad tolerant ProASIC freeze soon. But what else? Where else have they gone? I see a lot of people come to us talking about Igloo 2. We've done some Igloo 2 work recently for people and help them do some migrations with that. So where else outside of that niche and the edge have you seen sort of growth for your applications?
Yeah, so that's a good question, Adam. Again, I'll dive into a little bit of our success and where the engine of growth has been. So you're 100% right. Space and defense have been our stronghold, right? And the franchises that you mentioned, ProASIC 3, we had RTG4. Now we have something called RT PolarFire.
Yeah.
All of these have been extremely dominant franchises in areas of national security, space, and avionics. But let me expand on the bigger story, right? The crux of our growth, the core of our growth, is not actually in these markets. Although we are dominant, it's not actually in these markets. As I mentioned before, it's where power efficiency and security have really started to matter, right? So let's examine those. I think the first example that comes to mind are the killer applications on the edge, right? Take, for example, industrial automation, robotics, medical imaging. These are the killer applications that you hear about on the edge that requires intelligence. What do they need? So let's talk about those. The first thing is the metrics have to change from a lot of high performance FPGA gates to enough FPGA gates that deliver the highest GOPS per watt. Okay. Not just the highest GOPS, but the highest GOPS per watt, because these edge systems are, the size of your laptop, right? They're very thermally constrained. They have very little airflow, and there's no place to put fans and heat sinks and stuff like that, right? So again, this is where we start getting lucky, right? We thought this was coming, but this whole edge AI revolution that's starting to take place has really given us the tailwind that we needed to grow. So the core of our growth has been in these markets. When you couple that with the fact that you need deterministic control, you need determinism and low latency processing. This is where CPUs and MCUs are not that great, although they do very efficient processing. They don't do it with determinism and with low latency, right? So these areas of edge AI, industrial automation, medical imaging, robotics, these are the areas that we have seen, all driven by the way, computer vision, right? And we should not forget that. That's what's driven our growth. So while we, remain very committed to aerospace and defense as being the place where we need to have dominance, these other areas around edge AI have just, completely given us the tailwind that we need to become a very successful business.
It's a very exciting journey to see, and to see people working on it as well. I'm a big fan. I must admit, I am a big fan of the PolarFire. I like the PolarFire, and we'll talk about that in a little while. But it is quite a nice device. So do you see these sort of these sort of verticals that you see? Do you see them just in sort of like at the edge, or do you see them in more specific things, sort of like 5G or IoT or automotive? I mean, you mentioned just industrial automation, but I imagine that robotics also comes into play with a lot of this, and the demands for that.
100%. So whether robotics and industrial automation, they go together. Humanoid robots, anything that will deal with agentic AI. These are all areas of interest, right? Today, it's computer vision that is driving the need for these very capable low-power FPGAs. In the future, there'll be even more of this, but driven by agentic AI. Those are all sacrosanct, and for the next decade or so, they will power things. 5G, you mentioned 5G. So there are two areas of 5G that we've been successful in. One is all this data is going to be processed by the 5G backend, right?
Mm-hmm.
We can talk about 100 gig optical networks, but I think most people do not use wired networks today to access anything intelligent. It's usually done through
it's wireless, right?
Wireless, completely wireless. So from that perspective, 5G becomes the core technology of being able to access intelligence on the edge. We are designed into that. It needs determinism, it needs low power control, and it needs security. So those are interesting for us as well. And we are designed into some of the largest 5G backhaul networks in the world for cell site routers, and this is the reason why. So yes, the things that you talked about are very important. Automotive is another one that you mentioned. In the automotive world, ADAS is what people talk about. ADAS architecture is changing. It favored high-end FPGAs before and GPUs because everything was centralized. But I think what you're going to end up seeing is a distributed architecture where smaller FPGAs will be more prominent. An example of this is LiDAR, right? LiDAR systems actually do the processing at the LiDAR site, and they're very constrained. They're probably up on the windshield or something like that. So this is where low power FPGAs or power efficient, I want to correct myself, power efficient FPGAs will become more important, and we anticipate will participate in those as well.
Yeah, that makes a lot of sense. I mean, one of the key things when we talk to a lot of people about FPGAs and teach a lot of people how to design FPGAs, and one of the things we always stress with people is it's not just does it functionally work, but it's does it meet the power budget, and how does the thermal aspects of it look, and how can you get an actual a good thermal model of that FPGA to fit into the edge device so you can actually work out whether the system's going to be within its margins and things like that. So it becomes increasingly important. So I guess that takes us nicely on that we can have a chat about one of the devices that I was talking about earlier on, which is the PolarFire. Obviously, that seems to be your main push at the moment. You mentioned, for me, you've got the PolarFire RT or the RT PolarFire. PolarFire is interesting because it comes in the FPGA and it comes in the SoC version. So can you tell us a little bit about that leap? And it's because it's a big change, right? So you had the Pro ASIC sort of, and you'll have to correct me if I get this wrong in the history. You had the Pro ASICs, you had the Smart Fusion, the Igloo 2. You did the RTG4 for the space, but there was no real sort of equivalent to that on the ground, on terrestrially. And then you did PolarFire, and there's a big leap between those devices and the capabilities of PolarFire. So can you tell us a little bit about that?
So first of all, Adam, I have to say, man, your memory is like outstanding. You are 99% right. So RTG4 did have an equivalent, which was Smart Fusion 2.
Okay.
G4 is a moniker that we use for Generation 4 FPGAs. And we did not want to call it RT Smart Fusion 2 because it would be very hard to remember. So Smart Fusion 2 actually is our G4 FPGA, Generation 4 FPGA. Okay. And we just shortened it to RTG4. So that's the equivalent for the terrestrial system. Now, PolarFire, and when I see the smile on your face when you talk about PolarFire, I mean, it's kind of gratifying to see it. So I'm not drinking my own Kool-Aid. PolarFire was the turning point for us in the market. It was you have arrived moment, right? When you know it's like almost going home to your wife and driving that luxury vehicle and showing her that you finally achieved something, right? But this was that kind of a vibe here, right?
Yeah.
So it was a turning point to us. It showed the market that we had arrived. Because it wasn't just an incremental upgrade. It completely redefined what people expected out of mid-range FPGA. Okay. It was the first time that a mid-range FPGA delivered, GOPS at 50 to 75% lower power than what people are used to, and it was kind of mind-blowing. And this came from a non-volatile FPGA, and basically delivering this elevated security and SU immunity for free, right? That just came. If you used it, great. And now we are seeing cybersecurity becoming a concern, so people are using a lot of it. If you didn't use it, it was free, right? And then we also have an equivalent with SoC, with a microprocessor subsystem, hard microprocessor subsystem called PolarFire SoC, and that basically had a Linux-capable microprocessor subsystem where we made an interesting choice with RISC-V. So many people are like, "What the hell are you doing here?" And I mean, you're not a market leader to take such a big leap of faith, but it did open up new markets for us, like the one that I talked about, which is Edge AI.
Yeah, I think it's one of the questions I wanted to talk about actually, was that because everybody else seemed to go for the ARM cores, whereas you went for the RISC-V cores, and it seems I must admit actually my work has been more on the traditional PolarFire side than the PolarFire SoC side, because it tends to be that's what our clients are using, but it seems to be. And the flow seems to be there. It seems to work, and I'm curious as to how industry accepted it and adopted it and went with that SoC.
Yeah. So unfortunately, Adam, I have to tell you another story now. Okay. So hopefully this might be interesting for your audience as well.
Good stories are always good. I like stories
because it is an unusual choice, right? And at that time, it was seen as a crazy choice. Like, you guys just want to go bankrupt, I mean, why did you choose something that was not industry standard, which was ARM? And we use ARM products everywhere in Microchip. We use it in our FPGAs as well. Smart Fusion 2 has an M-class processor, right? It's an M3 processor, and we are very happy with it. It's adopted very well. But let's start off with the problem statement, right? It's always, you start off with an outcome and then work backwards. That's always the product planning philosophy. So we were in a dilemma. So we had set the standard with PolarFire and said, okay, we're changing the paradigm of how people saw mid-range FPGAs. How do we repeat that? It's the innovator's dilemma. I don't know if you've read the book, but that's the one that we needed to solve. The obvious choice right in front of our face was, let's do what everyone else is doing. Let's get an A-class processor. We needed this to be Linux capable, right? If you wanted to participate,
if you want to go to the edge,
you
need Linux, right? Yeah,
100%. So Linux, it had to be deterministic. So we need an M-class processor. We need real time. So we need R-class. So the classic way to do it is get a cluster together of A-class, M-class, R-class. Okay. Then we thought about our ethos, which was, how do we make this low power and secure? The only way to do this was to get an architectural license from ARM and say, okay, we'll take something off the shelf and then modify it so that we could be better than the competition. That would take transistors, it would take NRE, it would take basically not an act of God, but an act of a demigod, right? To actually get this thing done. So RISC-V had just come around. We were one of the founding members of the foundation that came out of Berkeley. And what we decided was to take a leap of faith. We chose a partner within that foundation that already had a company. And we said that these are the three things that we want. But we want to do it in the same processor cluster. So we want A-class, M-class, R-class. But the same processor cluster has to be able to do all three. And it has to be secure. Okay. We were able to do this without an architectural license with a partner by saying that if we do this, we first minimize the transistor count. We don't need 3 types of processors in this cluster. We just need one quad-core processor cluster, reducing the number of transistors, reducing leakage, reducing metallization, therefore reducing power. And then we added proprietary security to it because of our defense ethos and cybersecurity ethos. And that's how we came up with the choice. Now, in retrospect, was that a good choice? Right? That's the question I think you're asking. I would say that the RISC-V movement is well on its way to being one that is not only acceptable, but is accepted, right? And it's one that I think has threatened the very foundations of how you basically do embedded processors, right? And I think you've seen news around this. You have seen people and industry giants react to this. So the ecosystem is not, where it needs to be yet, but I think it's about 70 to 80% there. And I believe that I think any embedded processor company that is in business today has to be looking at this as an option. And I think we see the products out there in the market, whether it's from NXP, from ST Micro, or anyone else that are behemoths in this industry are considering this as an architecture of choice.
Yeah, it seems to be picking up a lot of momentum. RISC-V. It seems. I'd say I think your decision's very brave, but I think it's going to pay off. I think it's probably already paying off. So.
Yeah. Hopefully we were brave in the right way, not just foolish. So, but at that time there was a big split in our product planning team whether this was the right thing to do. I think in retrospect, this is going to pay off.
Yeah, I think so. I think it's going to pay off. So you have the PolarFire, you have the PolarFire SoC. You've just recently announced the PolarFire Core series as well, which is an adaptation of the PolarFire devices. And then you've also got the PolarFire 2 on your roadmap.
I'm just keep on getting surprised by your knowledge of a portfolio. But let me walk you through. I'll tell you a few more stories. So what happened in December of last year? Now I'm not going to comment why people did this because I think you have to ask those people who chose to do this as to why they did it. But without fail, starting from December 18th through December 23rd, 3 out of the 4 established FPGA vendors that we talked about decided to raise prices by 10% for between 40 to 90% of their portfolio. Why they did it is probably that their customers will have to ask them, and analysts like you will have to ask them, influencers will have to ask them. But what we chose to do at this point was, again, go against the grain. The discussion we had was twofold. Hey, everyone's doing it. We must do it as well to keep up, right? Otherwise, we'll fall behind. The prevalent argument that happened to win out was we have smallish market share. It's growing. So, we doubled it over the past decade. But if we just follow, just like with RISC-V, if we just follow the competition into this, why would anyone choose us as a supplier? So the decision that we made was a fairly simple one. We already had an existing portfolio. That existing portfolio could be modified very easily to basically, both from an operation standpoint as well as from a yield standpoint, as well as from a couple of other things. We just say basically take out the highest end of security that is used by the military establishment, and our estimate is about 30 to 40 to 50%, in that range. It's very hard to say, of edge devices today do not require high-end transceivers, right? So we decided to take that out. So what we did is we gave the market an alternative. Those people who are using these mid-range FPGAs, who are now faced with a 10 to 20% price increase, have a choice to come to us and say, since you have established the benchmark of prices for mid-range FPGAs, I can get something 30% lower than the competition. So that's what we decided to do. I think we chose the path of,
I think that's a really interesting. I think that's a really interesting approach, and it aligns well with the ethos that you talked about with the decisions about the SoC as well, where you were, you went with the RISC-V instead of the A class, and taking a different solution to what everybody else may be doing, and it paying off and helping you grow your market share. So is PolarFire 2 still on? Is PolarFire 2 still on the roadmap, Shakeel? Is that something that's going to be arriving on my desk soon?
Yeah. Yes, I believe so. It will be in a few months. I'm not exactly wanting to, at this point, to make a big reveal, but we did announce a PolarFire 2 architecture. Yeah, we did announce a PolarFire 2 architecture. It was about a year and a half ago that we announced it. We are in the final stages of wrapping up the active design. And just like you saw the step up with PolarFire and we changed paradigms, there'll be an even bigger paradigm shift on how we deploy this technology to offer even more GOPS per watt. Again, I don't want to do the big reveal here, but it will be soon. Watch out, over the next 6 months or so for further news on that.
Yeah, I think one of your people, Brian, he gave me a run through it a couple of months ago, and it looks really exciting, shall we say, for some of that. So one thing I do want to talk about actually, which is kind of leads us to segue into this, is I'm a big fan, and not only of the FPGAs that you use, but I'm also quite a big fan of some of the Microchip processors that are about. So for example, your SAM71 range of processors, we use those quite a lot. They come in automotive grade, rad tolerant grade, rad hard grade. We use them. We use them in a lot of our solutions, and I think that's one of the benefits that Microchip's now got. It's got a huge breadth of solutions and different capabilities, shall we say, that it can bring to people to help it. So do you see this as being a lot of synergy coming through there as you're beginning to align? I know there's some great app notes on sort of using the SAM71 to remotely program FPGAs and things like that.
Yeah, absolutely. I'm going to take it even a step further. So the first obvious thing is this concept we have inside of Microchip called total system solutions. Mm-hmm. It is an ethos based on, let's take the most prominent products that we have, our flagship products. And we have 4 flagship products. FPGAs is one of them. The center of the flagship is any processing elements. So as an architect, the first thing you will start thinking about is what is going to be your central processing element. So that it be a CPU or an MCU or a GPU, depending on how you're deploying your processing and where you're deploying it. The idea, and if you look at Microchip's portfolio, is that surrounding this central processor is basically, and let's be frank, an FPGA in many cases today is deployed as a central processor. It's surrounded by power, timing, programming elements, analog, and sensor interfaces. And Microchip is one of the few vendors in the world, semiconductor vendors in the world, that has all of these elements. So it just follows. And if you go and look at our website, you will see this, big diagram that shows FPGAs and MCUs in the middle, and then all these peripheral things outside. So every salesperson makes sure that the story is prominent. That we are a one-stop shop. We're a one-stop shop, especially for companies that do not want to think about all of this stuff and go to different vendors and figure out how to make everything work. We try to, kind of give them a canned solution around this processing element. So that's number one. That's the obvious one. The second, less obvious one is, since you talked about SAM71, Microchip's legacy is being the fact that it's a completely dominant player in 8-bit MCUs, and it has a growing presence in 60 and 32-bit MCUs and MPUs. Microchip doesn't want to stop there. It has a desire to grow beyond that to 64-bit, so that they can get into real heavy lifting of processors.
Yes.
Guess who has a 64-bit processor? FPGAs.
You do.
The PolarFire SoC.
Yes.
Yes, exactly.
PolarFire, yes.
So that has derived a series of derivatives. We have something called PIC64 that has come out. It serves the space market with HPSC. We did this in partnership with NASA and JPL.
Yeah, I've been looking for a project. Actually, we've been looking at that PIC64. It's quite impressive.
Yeah. It's got TSN. It has a lot of capabilities. That's vector processing. Really, really cool part that will drive innovation in space for the next 15, 20, 30 years, right? Then we have PIC64HS and GX, which are lower end derivatives, but this is the speed of innovation that RISC-V gave us, right? We already had a microprocessor cluster subsystem. We upgraded it, and then we released 64-bit to the market. The other thing that you will see is Microchip's desire to make sure that we do not miss the AI/ML tailwind that is basically shaping next generation MCU, MPU architectures. Again, guess who's the pioneer inside of Microchip to bring AI/ML algorithms into processing elements? Again, it's FPGAs. So the next thing you're going to see, exactly. So I think the next thing you will see, and I was like a core part of the Tiger team that was formed to figure out how we bring these capabilities into MCUs and MPUs. You will see what we learned inside of FPGAs and how to do machine learning algorithms will be deployed inside of our MCU and MPU architectures as well. So coming soon.
That's quite interesting, and I like that. I like that sort of total system solution. I like that total system solution approach. As somebody that has to architect systems quite often, it makes it a lot easier for me to be able to sort of pick elements that are going to be available and going to work together and give you that steer in the right place. So we've touched on a lot of sort of the FPGA history and talked about the roadmap and AI/ML and all the exciting things related to the silicon. I want to put my evil hat on for a minute, or my hard interviewing hat on for a minute, and I'm going to ask you about software and tool chains and development, because this is really where it's where as FPGA engineers we spend a lot of time battling tool chains and trying to get it worked out. I'll be blunt, Libro doesn't have the best reputation out there as a tool chain. So what does your roadmap look like for sort of supporting the PolarFire Core, PolarFire 2 and legacy devices in that sort of FPGA and SoC world?
Yeah. Okay. So this is a question that is laden with a lot of truth, right? We have built our reputation and our market growth and our market share story around silicon. So people come to us because we have superior silicon for some of the things that people are trying to do today. Okay. Libero is not what people come to us for, and it is one that we have been grappling with, right? So the design tool is critical. The 20 to 25 failures that I talked about in the industry over the past 30 years, 90% of them failed, not because of a bad business model or bad hardware. It's because of software, right? And converting vendors is difficult enough without having to encounter bad software, right? So design tool is critical. So we have made some serious strides. The complaints have been around scriptability, stability, intuitiveness from the sense that the GUI looks outdated, and it is one that is whose base is about 20 years old. It has its quirks. So we have introduced a new Libero series starting with 2025.xx. And what I would urge the people who are listening to this is to go give it a try and see if things have improved, especially around scriptability and stability, which are two things that we always ask for. Despite these changes, we still get criticisms, and the core criticisms around tool speed, and this is again born out of a database that takes up a lot of memory. It's not very memory efficient, right? So we have made improvements around it, but they are evolutionary and not revolutionary improvements. what you're going to see, Adam, and as a user, and I think maybe Brian would be a good person to ask for you to do this, is test drive PolarFire Studio. PolarFire Studio will come out concurrently with PolarFire 2, because we need, for a new software to be really tested out in the market, you need a new architecture to test out a new architecture. So they're concurrent. I believe, and I hope I'm not drinking my own Kool-Aid here, is that those core criticisms around modernity, stability, and stability is directly related to memory usage, failure mechanisms, and making sure that failure messages are intuitive, scriptability, which gives you control over automation, design automation.
Yep.
And the most important thing is abstracted design flows. Today's computer engineer is not going to may not even touch RTL or HDL at all.
It's surprising. Yeah, it's surprising how little HDL I write these days. Well, you want to be at the highest level of abstraction you possibly can be to get the best out of those devices.
100%. So Studio will combine all of these together. We made 2 acquisitions over the past 5 years. One with the company that did AI ML algorithms, and the other one that did high-level synthesis. We have combined that the core of those technologies, inclusive of SoC design, and are going to combine them into PolarFire Studio System Designer. And we are hoping that we can give you an early look at that as well, and you can tell us if we are on the right path.
Yeah, I'd love to take an early look at that. I saw some Joe's presentation at it at the ESA conference a few months ago, and I've had a bit of a chat with Brian about it, and it looks really interesting. And I will go down and download the latest Libra as well, and throw a blog or 2 out around that. So we've kind of covered a lot of the world, and I'm conscious of time because we're both quite talkative here. So one of the things I was interested about, how do you obviously we do a lot in the community. So how does Microchip engage with the community? I know you're coming to you're sponsoring our conferences that we're having, FPGA Horizons in the US and in the UK. But obviously, the community is a big part of it, and a big part of the success and the feedback as well. So how does Microchip engage?
So the FPGA companies are the experts, right, in trying to basically put together a solution that you guys, the community, has given us 2 clues to, or told us your needs. You can't do that through data sheets. You can't do that through tech support. Post-COVID, I believe that, and given the complexity of FPGAs, and FPGAs not just being glue logic, but things that serve system-level solutions. So we can break down silos by providing reference designs, by providing data sheets or good application notes, good tools, but that interaction with the FPGA engineer, which is becoming a shrinking community. I mean, if you just look at what our universities are churning out today, there is about a ratio of 100 to 1 between computer science and computer engineers to FPGA engineers, right?
Yes. Yeah.
There's less and less people that are doing custom hardware logic design. Combining these communities. Go ahead, Adam.
No. So I would say I joke often that there are more giraffes in the UK in zoos than there are FPGA engineers. I've never been around to actually try and count it, but it's a very valid point you're making, that there are fewer and fewer FPGA engineers coming out the pipeline.
That's right. So conferences like what you are participating in, and what your institution is championing, like FPGA Horizons, they are incredibly important to our industry. Incredibly, that one-on-one time, what's coming next. FPGAs have long gestation periods. Between the time you decide on architecture and actually implement a system using FPGAs, could be up to 36 months, maybe more.
Yeah.
You want the earliest look at what's going on. Listen to the subject matter expert. So I don't care about Zoom and this live stream. The only way for me and you to talk meaningfully is for me to come out to Harlow, and I can't do that. So I'll have to meet you at the FPGA Horizons.
How about you come to FPGA Horizons?
Nice.
Actually, I have an employee in New Jersey, so next time I'm in New Jersey, I'll swing via Allentown.
Yeah, maybe I'm just old-fashioned, but I think these face-to-face time and breaking down the silos between computer scientists, computer engineers, architects, and the little community of FPGA engineers we have, these kind of events are like outstandingly important.
Yeah, no, I'm a big believer in that as well. Yeah, people Zooms and stuff that they have for their use, but actually, at the end of the day, there's nothing beats actually talking to somebody face to face, and just sort of, like you say, understanding their issues, their challenges, their wants, their desires, their and trying to help them get a solution. So, and thank you very much, by the way, for being involved with our conferences. We do appreciate it.
Absolutely.
So, what do you see? Where do you see this? Where do you see this landscape going over? Where do you see sort of the FPGAs going over the next 5 to 10 years? If you were to not necessarily give away any super secrets that you've got, but where do you personally think that they're going to go?
I think it might do your audience. I might do your audience a favor by not just talking about microchip FPGAs, but I'll talk about trends. Right? We touched upon them throughout our conversation. Yeah, go ahead, Adam. Were you saying something?
No. I think trends are a great idea. I think trends is a very good way to look at it.
Okay, so let's start with the mega trend: intelligence on the edge and FPGAs. Right. So I don't think that there is an end I can foresee to this thing. Robotics, agentic AI, generative AI, computer vision, all this will continue to evolve 5-10 years. This revolution is gonna take a long time, right? It's going to power economies of the world, and FPGAs are going to be central to this thing. So if you look at anything 5 to 10 years out, these are the trends that we need to solve from a product standpoint, right? One is continue delivering the lowest GOPS per watt, or the highest GOPS per watt, and the highest GOPS per millimeter squared. That is a mega trend inside of FPGAs that is undeniable. Whoever it is, it could be our competitors, it could be us, whoever out innovates in this area with these KPIs and metrics are ones who are going to put themselves in the best position. Counter to this is this challenge. The innovators of today are not necessarily just FPGA engineers, and no disrespect to them. It's the computer engineers and computer scientists of the world who are writing algorithms in languages other than Verilog and VHDL. So how can we bring abstracted tool flows to this? Again, the companies that are able to innovate in abstracted tool flows, bring AI ML inside their tool flows without these engineers having to know an ounce of custom logic in depth, are the ones that are going to be able to succeed. C++, we could keep on talking about it. What's going to happen next? Probably Python, right? So there are projects all around the world that they're open source projects that are trying to figure out how to use Python, not just for design automation in FPGAs or scripting, but also to figure out how to actually do an actual FPGA design using Python.
Yeah, Amaranth's one of those, right?
Adam,
there's quite a few of them.
Yeah. So I think these are the two trends that we need to look at. One is highest GOPS per watt, highest GOPS per millimeter squared, and absolute.
Oh.
Did I lose you?
No, I think you're back now. Yeah, you froze a second. Yeah.
Yeah. So I think your audience might want to examine those statements, but I believe those are the things that we need to work on.
No, I think that makes a lot of sense and resonates with my thoughts on it. It's all about that processing power, that innovation at the lowest power, and then the problem that brings, it's the kind of the two go hand in hand, because if you've got all this capability, you can't actually design at VHDL and Verilog. Much as it's fun to sit there and write it, you've got to be a lot more productive. You've got to be leveraging high level tools, AI tools, and however you can to try and get your project across the line and get to market first. So I'll begin to wrap up now. So I've got one last question for you. Really, I mean, obviously, both of us have been in the FPGA industry a fair while. You slightly longer than me. You've got some great history there, and it's been wonderful to talk to you about it. But what advice would you give for anybody that's watching this stream? Who's a young engineer, just thinking at college or coming out of college and thinking about wanting to get involved in the FPGA space. What piece of advice would you give to them?
Okay. So I'm talking to you, young engineer. So, and I'm going to expand my advice, not just to the young engineer, but anyone who's attached to bringing innovation, whether you're a nation state, a government, a young engineer, or a computer engineer who's worked on MCUs and GPUs forever. FPGAs are foundational to heterogeneous compute. The more we limit ourselves to one type of favorite processing technology, the more we're limiting ourselves, our careers, our futures as nation states, including the ones in the Western world. And we're limiting ourselves for the companies that we are working for as well, that want to bring innovation. Over the past 30 years, you look at any trend that emerged. At first, it was flexibility with glue logic. Then it was wired networking with optical networking. Then it was database wireless systems, 3G, 4G, 5G. And now it's data centers and edge compute. The singular technology that emerged and took advantage, that people took advantage of to drive innovation, was FPGAs. It is a sacrosanct part of innovation over the past 3 decades. Learning it is almost mandatory, in my opinion. Our job is to make it more accessible to you. So over the next few years, everyone in the FPGA industry is going to try and make this more accessible so that you don't have to worry about the underlying hardware. All you have to do is harness the power of FPGAs in delivering that innovation. And, there are many, many examples of things that you could do today. We have a discovery kit today. It's like $100, $150.
Yeah, I have on the grid.
If you don't go, if you don't go for one expensive dinner, maybe you can buy and play with those. But basically, the idea there is to right away take a problem around intelligence and use an FPGA without having to know too much about them. So that is how we are going to try and make it accessible for you. But I have to emphasize that if you're a company, a nation state, a young engineer, a computer engineer, make sure that you do not ignore FPGAs. It is a foundational part of the past 3 decades of innovation in electronics.
No, I think that's a very good point. They are the foundation stone, the cornerstone of pretty much most. If I look back across my 25-year career, they're the foundation stone, cornerstone of pretty much every solution that's been there, and that drive to high level abstractions and to not having to worry about the lower level logic side is quite interesting, and it's been a push for a long time. I remember Handle C back in 2000, I think it was the first time I came across that push to high level stuff. But actually, these days that was kind of before its time, really. These days the devices are capable. The computers we've got to actually do the EDA on and to generate these, it's all kind of coming together to allow to facilitate that high levels approach and abstraction. So I guess that takes us to the end of the hour. It's gone really quick. It's been fantastic talking to you about FPGAs and Microchip FPGAs. And I hope we do get to meet in person at one of these events. But yeah, Shakeel, thank you so much for coming to talk to us today and sharing everything that you have. And hopefully, I'm looking forward to finding out more about the PolarFire 2, PolarFire Studio, and we'll keep working away with the PolarFires and the RTGs and the ProASIC 3 RTs as we do cool engineering. So thank you very much.
Yeah, And likewise, Adam, I think you're doing a big service to everyone in FPGAs, not just us. I love reading your blogs, and keep on doing the good work that you're doing.
No, thank you very much, and thank you everybody who's joined us and watched us for the last hour.